Not all brains develop in the same way, and for some this can lead to quite specific difficulties with learning, such as dyscalculia, which involves problems with numeracy.
Could you count in twos for me and see how many twos we've got on the table? How many groups of two?
Toby is dyscalculic. He's bright in all other subjects, yet a basic maths problem confounds him. He can't make the usual connections.
14.
15.
Nearly. 14.
16. 7.
18. 20.
Professor Brian Butterworth is the leading authority on dyscalculia in the UK.
Dyscalculia is a problem in acquiring numeracy. Specific to numeracy, it doesn't apply necessarily to other branches of mathematics. It's really a problem of understanding simple number concept. How the brain processes maths is slightly complicated. It involves two areas of the brain, here in the parietal lobes and also in the frontal lobes. And the important thing to remember, particularly in relation to dyscalculia, is that the numerical processing is essentially a parietal lobe function.
One of the implications of Professor Butterworth's research is that the highly specialised system in the brain used to process simple number concepts is defective. Here at Emerson House, Specialist Support Centre for Children with Numeracy and Literacy Difficulties, they work to help children deal with dyscalculia number problems by using very structured multi-sensory teaching, focusing on sets of concrete objects.
Most dyscalculic children are not able to subitize, which means they can't recognise small arrays of dots without counting them one by one, whereas typical children would see 3 dots and just know it was a 3. So we train these children using familiar dice patterns, which most young children know anyway. So we've got the dot pattern of 6, 3 and 3, and we've got the dot pattern of 8. Which two numbers can you see in there hiding?
4 and 4.
It's very important that they are trained to reason from key facts, such as 5 and 5, because reasoning is the one thing that dyscalculic children find very difficult. Can you make 11 for me now? How do we go one more? 10.
11.
Carry on. One more.
11. 20.
Careful. 11.
12.
12.
At the moment, one of the problems is that most people take the view that the child is stupid. That teachers take this view very often. Parents certainly take this view. Children themselves take this view. Why is it that they can't add 3 plus 3 even though they're 9 years old? Has to be because they're stupid. If you can demonstrate that there's something specific, confined in the brain of that child, then the diagnosis won't be stupidity, it'll be something specific. Rather in the way that 30 years ago people were able to demonstrate that dyslexia is a specific disability, and more recently it's associated with abnormal brain structure and abnormal brain activity.